With the final exam just days away, I'm going to show you 3 easy steps to maximise your grade using minimal effort. Step 1. Head to TGMT Upgrade. You can now get 5 days all exclusive access for just £10, and that includes the foundation or the higher course. So once you are in the hub, you will now be able to access within foundation and higher for Edexcel or for AQA bespoke quizzes that go through all the topics that haven't yet appeared on papers 1 and 2. You can go through the quiz, you can answer the questions, answering something on every topic that has not yet appeared. Step 2, you can then get a full report which is going to show you exactly what you got right and wrong. So you're going to be able to focus on those topics that you know that you need to focus on. Step 3, you can then go back into the hub and you will get all exclusive access to every single unit and every single quiz within the hub. So you're going to be able to go to those ones that you know you need to work on, you're going to be able to access the full lesson and each individual quiz for that unit. So you'll be able to answer questions on the topics that you know that you need to work on that haven't yet appeared. You will also get a full report for each of those questions, so you'll know exactly what you need to work on. With the exam just days away, we need to make revision simple. Join Upgrade. Okay, welcome to this video. We'll be having a look at a practice paper for the paper 3 higher tier exam. This is a calculator paper, so do make sure if you're following along you've got a calculator at the ready. Now, as with all of these, we will be covering topics that haven't yet appeared across papers 1 and 2, but of course these are not going to be all of the topics, so do make sure that you check all of the links in the description and check out any of the other videos that are going to accompany this to make sure you get a full coverage. But as always, do make sure that you check the full checklist, which you can download in the description also, and just make sure that you are happy with all of those topics and not just the ones that are in this paper. As always, there will be a QR code on the front, so if you've got this printed, you can get back to the video at any point, but we are going to get started as we've got a lot of questions to get through. Now, question 1, we have working out the median, and we're looking for the class interval that contains the median. So here, when we are trying to find the median, we're going to look at the total number of days. Here it's 60. If we divide that by 2, that's going to allow us to find where the 30th day is. Now, there are other ways of finding the median as well. There's a more statistical method where we add 1 and halve it, but typically we will get down to our median class using this middle number just like this. So if we count down cumulatively, we start with 8, and when we add the next 24, that gets us to 32. Now we have gone past the middle, 30 would be just above that somewhere, but it's in this category here, the 5 to 10. So we would write our answer exactly as it's shown in the table, between 5 and 10. You can be asked a few different things from a table like this. You could be asked to find the modal class. The modal class is the most common, which would actually be the same category in this case, because that happens 24 times. You can also look at the mean from a table as well, which is where we take the midpoints, multiply across, and find those totals, and then divide our total answer there by 60, as there are 60 days. But here we are asked in part B to draw a frequency polygon. So we're going to have to find all those midpoints. So here, if you're not sure how to find the midpoints, you can add together the start and the end of the class. So for this last one here, which is 22.5, you can do 20, add 25, and divide your answer by 2. That will give you the midpoint, but I'm going to go ahead, mark all these midpoints on to make sure that I plot these points in the right place, and then we just need to plot that against the frequency. So 8, 24, and 13, we would have 8, 24, 13, just make sure that you check the scale to make sure that each square represents 1 or otherwise. Then we have 11 and 4. So 11 and 4. From here, we want to join these points up, dot to dot, from left to right, using a ruler and a pencil. We want nice straight lines. You want to make sure that you hit the points with every single line. I can just about get them to hit perfectly. And there we go. So all we do is we join it up from left to right, dot to dot. We don't need to connect them at the bottom. We don't need to join it to the axes. It literally is from the first point to the last point with nice straight lines using a ruler and a pencil. Okay, on to our next question. We're looking at some compound interest. Now I would pretty much exclusively use a multiplier for compound interest. For 3%, when we're starting with 8,000, the multiplier for 3% is 1 point. Now for every compound interest question, the percentages typically are always going to be less than 10%, so it's always 1.0 something. So for 3%, it's 1.03. If you don't recognise your multipliers very easily, well, you can add 3% to 100, which gets you 103%. And if you find your percentage button on the calculator, you can literally type in 103, click percent, click equals, and it will give you the multiplier 1.03. Now this question here, we get 3% in the first year. After that, we get 1.5%. 1.5% is 1.0 again, and then just 1.5. So these are the two multipliers that we're going to use. We get the 1.5% for every additional year, but we only get 3%, or we get the 3% in the first year. So 8,000 times 1.03, you can write down the answer for that, but because we're going to times the answer by the next multiplier, I would probably just do times 1.015, and you can either write that out again, or as we're getting that for 2 years, we can put a squared with that one. As we want to do that one twice, we can type it all in one go. So times 1.03 times 1.015, and we want to make sure squared is with the 1.015. We can then just click equals, and we get our answer here. It comes out as £8,489 and 5 pence. There is a 4 after the 5, but we're rounding that to the nearest penny, and there's our final answer. As with all these questions, make sure anything that you type on the calculator screen, you write on the paper. So exactly what I've written on my calculator there, I've written on the page. And there we go, there is the value of the investment at the end of 3 years. Just watch out for the language there. Sometimes it does say, calculate the amount of interest, where I'd have to subtract the original 8,000. But this one wanted the value of the investment. Our next question is looking at a Venn diagram. So we're given the numbers 1 to 9 to put into our Venn diagram. We then have numbers in A and numbers in B. We want to find out what numbers are in both. So here we have a 6 in both and we have a 9 in both. So they go into our intersection, 6 and 9, and we're going to cross those off from the main list. In A, we then have 1, 5 and 8. We're going to again cross those off from the main list. In B, we just have the number 2. So crossing off the 2. You can see now that we are left with 3, 4 and 7, and 3, 4 and 7 go on the outside of the circles. So now we've completed the Venn diagram. Typically we'll be asked a question about it. It says here a number is chosen at random from this universal set. Find the probability the number is in set A dash. A dash means not in A. So if I was to put a circle around A, so just highlighting that A circle, it cannot be within that circle. So the only numbers not in the circle, we have 2, we have 3, we have 4, and we have 7. So there are 4 numbers not in the A, so that's 4 out of, and there were 9 numbers in total, so 4 out of 9. So there we go, they're the numbers not in A. Remember, you can be asked about the union and about the intersection as well. So the intersection, which is the little N shape, which is in the middle only. So that is the 6 and the 9. And there's the intersection. Or you can be asked about the union, and the union is everything within the circles, including the intersection. So 1, 5, 8, 6, 9 and 2. So there we go, they would be the numbers in the union. So there we go, there is a Venn diagram and some set theory, specifically looking at the not in A part of this set theory here. Okay, so this question, we have a right-angled triangle and a quarter circle. It says to work out the perimeter of the shape and give your answer to 3 significant figures. So we've got quite a lot of working out to do here because we only have 2 parts of the triangle. We've got the 9 and we've got the 6, which means we are missing this length here, the radius of the circle, which is going to be the same as this one just here, as the radius is the same all the way around a circle. And we are also missing the curved part of the arc over here. So for the missing line C to D, we can find this line of the triangle using Pythagoras' theorem. It's a shorter side, so we'll do 9 squared, take away 6 squared, and I would normally just put that all under a square root, so it gives me my answer straight away. So the square root of 9 squared, take away 6 squared, and that gives me 3 root 5, or as a decimal, 6.708. Now it says to give my answer to 3 significant figures, so I do want to leave my working out to more than 3 significant figures, ideally as accurate as possible. I'm going to put another 2 in there, and that keeps it to 5 significant figures. That's just going to avoid me having to write down tons of numbers, but I'm going to try and keep the numbers in my calculator as much as I can. So that is up here, 6.7082, and we only have one line left to find. Now the other line that we have to find here is part of the circumference of the circle. So the circumference of a circle is pi times diameter, or 2 pi r, depending on which one you use, and this is only a quarter circle. So when we are looking at circle sectors, we're going to think about what fraction of the circle it is. A quarter circle is a nice one, as it's 90 out of 360. That simplifies down to a nice 1/4, and we can go about working out the part of the circumference, the arc length. So for the diameter, we do want to double the radius. So the diameter, which I'll write to the side here, is going to be 2 lots of the 6.7. So I'm going to press times 2 on my calculator, and we get a diameter of 13.4164. So I can do pi times 13.4164, and I'm going to multiply that by the fraction of the circle, which is 1/4. I'm going to type that all in one go. So times by pi times by 1/4. And there we go, that gives me a length of the arc, which is 10.5372. I'm going to label that up here on the diagram, 10.5372. And now, just thinking about this concept of perimeter, we want to add together all of those lengths. So we have 9, 6, 6.7082 and 10.5372. Now ideally, I'd write those all down in a big long addition. I'm going to type it on my calculator anyway, but I want to show that I'm adding together these lengths. So I'm going to write that down, 10.5372, add 6.7082. There we go. I'll get a final answer for that. It is going to want me to round the answer, of course, but I'm going to type them in, 0.5372 plus 6.7082, and that gives me 32.2454, and we want to round that to 3 significant figures, so 32.2 metres. And there we go. There is my final answer for the perimeter. Now, of course, a lot of different topics in there. You've got Pythagoras' theorem, again for a shorter side, and we had a bit of circle sectors. Although it was a quarter circle, which is quite nice because you can just divide your answer by 4, we've still sort of taught and mentioned this concept here, because if it is a different angle that isn't a nice fraction, you do want to use that method there instead. Okay, so on to our next question. We are looking at some exchange rates, and we have some best buys in here as well. It says Sam pays €27 for 18 litres of petrol, and in Wales Leo pays £40.80 for 8 gallons. We're then given some exchange rate. €1 is £0.85, and we have a conversion, 4.5 litres is equal to 1 gallon. Sam thinks that petrol is cheaper in Spain than in Wales. Is Sam correct? And you've got to show how you get your answer. So when we're making comparisons like this, I do always like to split the page. I'm going to have a look at them both separately. So we have Sam and we have Leo. So for Sam, he pays €27 for 18 litres. Now typically for questions like this, I would always convert this into my home currency. So for us that's in pounds. So for this one here, we are going to do 27 multiplied by 0.85. That's going to turn it into pounds. We can do that on the calculator. So 27 times 0.85, that comes out as £22.95. So that means we now have Sam, who pays £22.95 for 18 litres. So 18 litres is equal to £22.95. and 95 pence. We now want Leo in the same amount. Now his is already in pounds, but his is in gallons. So we want to change these gallons. It says it's 4.5 litres for every 1 gallon. So 8 times 4.5, we'll turn that into litres, and 8 times 4.5 comes out as 36 litres. So now we have Leos in gallons to litres. We can write that down. So 36 litres is equal to, and that was £40.80. Now what we need here is a comparable amount. At the moment we have 18 litres and 36 litres. This particular question is actually quite nice because 18 litres can nicely turn into 36 litres by just timesing by 2. So we get a comparable amount relatively nicely here. The difficulty of course was getting them into the comparable figures. £22.95 times 2 comes out as £45.90. Now there are other ways to do that. We're going to first write an answer here because this was the nicest, quickest way to do it. But you can see here that Leo's 36 litres costs less than Sam's 36 litres. So Sam thought it was cheaper in Spain. Actually, no. We have, is Sam correct? No, Sam is not correct. And it's backed up with nice clear working out. I've even highlighted the smaller figure there. And we have Leo's is cheaper. So no, Sam is not correct. Now with values like this, of course, mine was quite nice here because it turned into 36, but if it didn't, we could have divided by 18, that would have given us the cost of 1 litre, and then we could have divided by 36 to get the cost of 1 litre. And you would see there you get smaller numbers, but that is another option that you could use to make a comparable figure as well. So £22.95 divided by 18 would give us £1.275 or £1.27 and a little bit extra. And for the other one, £40.80 divided by 36. We get a recurring decimal, but it's 1.13 recurring. So if we round them to the nearest penny, we've got £1.27 and £1.13. So again, you can see Leo's is smaller per litre there, and therefore no, Sam is not correct. Whichever method you prefer, but of course that concept there of getting everything into the same units before making that comparison. Okay, our next question is looking at a scatter graph. So this one here says the scatter graph shows the information about the amount of rainfall in millimetres and the number of hours of sunshine for each of 10 English towns on the same day. One of the points is an outlier. Write down the coordinates of this point. Now an outlier is normally relatively easy to spot. However, I would always first recommend drawing a line of best fit, which goes generally through the points in the general direction. Now, every line of best fit will be slightly different. You need to use a ruler and a pencil, but we want to get it as best as we can through the points with around about the same above and below. From there, you can see there is a point here which is lying further away from the line of best fit to all the other points, and that is our outlier. So that one there has an x coordinate of 2 and a y coordinate of 1. Again, just trace down very carefully, make sure you read those numbers perfectly. For part B, it says, ignoring the outlier, describe the relationship between the amount of rainfall and the number of hours of sunshine. Now this type of question is not asking for the correlation. Here, this has a negative correlation. It's sloping downwards, so if we were asked about the correlation, we would say it has a negative correlation. This is asking about the relationship. Now when we're asked about the relationship, we want to use these words that are on the axes. So what is happening as the number of hours of sunshine goes down? Well, as the number of hours of sunshine goes down, the amount of rainfall goes up. And that's one way that you could describe it. You could reverse that, and you could say as the amount of rainfall goes up, the number of hours of sunshine goes down. So that is how we describe a relationship on a scatter graph. Now you've got two options there. You could write down either one. I'm not going to write that one down. We're going to have a look at part C, where it says on the same day in another English town, there was 7 hours of sunshine. Using the scatter graph, estimate the amount of hours of rainfall in this town on this day. So for 7 hours, we want to find the axis that has hours on. Highlight the 7, so we go across from the right place. We want to go across to our line of best fit, nice and carefully. And then we want to go down to our other axes. We're going to read this number very carefully, just about get it in there. And there we go. So that is 3. And then just past that, each square goes up by 0.2. That's just in between a square, so I'm going to read it as accurately as I can. Mine comes out as 3.3. There will be a range of values that you're allowed because it does depend on how your line of best fit is drawn, but it's going to be somewhere close to 3.3. Don't worry if yours is slightly off, just make sure that you do show that line going across and down to your line of best fit, as you've got method marks there for using a line of best fit. So there we go, my answer comes out as 3.3, but there is a little range of values that you would be allowed for a question like that. Our next question is looking at a plan and elevation. So here we have a prism with a cross section in the shape of a trapezium. Now it says on the centimetre grid below, draw the front elevation of the prism and use a scale of 2 centimetres to 1 metre, which means that 2 of these squares here represents 1 metre. So if it's 2 squares for every metre, we can times all of these metres by 2, and that's going to give us the amount of squares or the amount of centimetres that it is. So this would be 4, this is going to be 4, and this is going to be 1. Of course, you can use a calculator for that, although 2 times 2 is a relatively nice one to do. So we've got the base and the height that are both 4, so we want to position this somewhere where we're not going to go off the grid. So there's 4 across, there's 4 up. We had the 1 on the right, and then this last diagonal line, we don't need to worry about measuring that, as it's just connecting these 2 points together to finish off our elevation. And there we go, there is our front elevation for that trapezium that's on the front, using that little conversion in this one as well, just being really careful with that. Okay, so there was a plan and elevation. Now we have some pressure, force and area. It says here the diagram shows a cube and a cuboid placed on a horizontal floor. The total surface area of the cube is equal to the total surface area of the cuboid. The pressure on the floor due to the cube is 2.35 newtons per centimetre squared. Work out the force exerted by the cube on the floor. Well, looking at our formula, we have been given the pressure. We are asked to work out the force, but we are currently missing the area. So we need to know the area of the base of the cube, just here. Once we know the area, we can put it into our formula and we can work out the force. So we're going to use this bit of information. The total surface area of the cube is equal to the total surface area of the cuboid. So we need to work out the surface area of the cuboid. The cuboid has 3 different surfaces, the front, the side, and the top just here. So I'm going to work out the area of each face. 1 would be 6 times 8. 2 on the side will be, and label the sides, 6 times 18. And the one on the top, we've got 18 here, 8 there, so it's 8 times 18. I'm going to get my answer for each of these, and because it is a cuboid, I am going to multiply my answer, of course, by 2, because there are 2 of each face. So 6 times 18 is 108, 8 times 18 is 144, and let's add those all together. That gets us a total 300, and we're going to times that by 2, so that's 600 centimetres squared. So that's the surface area of the cuboid. Now, because they're equal, that means the cube also has a surface area of 600 centimetres squared. Now, if the cube has a surface area of 600 centimetres squared, we can use our knowledge of a cube because all of the areas, all of the faces are the same size. So a cube, which of course has 6 equal faces, if its surface area is 600, then we would want to divide that by 6, which gives us the area of one face, which is 100 centimetres squared. So if the area of one face is 100 centimetres squared, then the area of the base is also 100 centimetres squared. So here it says the pressure on the floor due to the cube is 2.35. We now have the area of the base, so we can put our pieces into place. We have the pressure, which is 2.35. We'll use our formula here. So 2.35 is equal to the force over 100, the area, and we just need to rearrange that, so times both sides by 100, and we get that 235 is equal to F, and that is our force. So our force there is 235 newtons. So a relatively nice one. Our working out there is a little bit all over the place, so just be a little bit careful. Obviously I've got to scroll up and down, but our final bit of working out is just up here, and that was our key piece of working out. Let's just double underline that to get our final force figure there. Now in that particular question, you didn't actually need to work out the length of the cube, but if the face is 100, you could also square root that, and we could figure out that all of these side lengths are also 10. We didn't particularly need it for this one, but we could even work out the volume of that if we needed to. But there we go, didn't need any volume for this one. We're just working backwards to get that area of the face. Okay, question 9. Saffron wants to work out an estimate for the total number of fish in a lake. On Friday, Saffron catches 180 fish from the lake. She puts a tag on each of these fish and puts them back into the lake. On Saturday, Saffron catches 305 fish and she finds that 45 of them are tagged. Work out an estimate for the total number of fish in the lake. So this is capture-recapture. Here we have a sample that we have caught, 45 out of 305, and here we have the first sample, which was 180, but we don't know the total. So in the first capture, it was 180 out of, and we need an unknown or use the letter X. In the second capture, the tagged ones, we have 45 out of 305. Now what we're going to do is we are going to assume that these are equivalent and use that to help us figure out what that value of X is. Now there are two different ways of looking at this. I like to just think, how do I get from 45 to 180? So that's 180 divided by 45, which is multiplying by 4. I can now do the same to the denominator, times by 4, and that's 305 times 4, which gives you 1,220, and that is our final answer. Again, that's not the only way of doing it, so 1,220 is my final answer there. You can do 305 divided by 45, and then you can times that by 180 if you prefer to work around your fractions like that. Just be really careful because you do have some recurring decimals when you do that, and you need to leave that in your calculator. Whereas going from 45 to 180 here gave me that nice whole number of 4, so I didn't need to worry about any recurring decimals in my calculator. But there we go, there is some capture-recapture. Okay, question 10. Always love these questions. You normally only get 1 mark for them, but it is a graphical simultaneous equation. Typically the equations look overly complex, but it wants us to find a solution to these simultaneous equations. And this is just understanding what the solution to simultaneous equations actually is. It's just the point where they cross over. And that has a coordinate, which has an x value and a y value. The x value is -2. The y value is +4, so our solution is x is -2 and y is equal to 4. There we go, and there's our final answer. So x is equal to -2, y is equal to 4. I don't know why we've put y there, change that to an actual 4, and y is equal to 4. There we go. So there we go, there is a graphical simultaneous equation. Okay, so looking at some algebraic fractions. They can have lots of different types of algebraic fractions, so you do need to make sure this is one of those topics, especially, like I've mentioned at the start there, that you can't just rely on this one question on algebraic fractions to make sure that you are happy with all of algebraic fractions. You've got multiplying, dividing, adding and subtracting is very similar, but you've also got those algebraic fraction questions where there's 3 fractions being added or subtracted, and they can get quite complex, and there's lots of different types, as well as simplifying algebraic fractions. So again, I will link the videos in the description for this topic, but definitely one that I would suggest making sure that you do have a look at, just to make sure you've practiced all those different types. Now it follows the same rules as normal fractions, so here we are adding, so we do want a common denominator, so I'm going to take the left denominator and times that by the top and bottom on the right, so we're going to times by x plus 2, and the bottom right denominator, x minus 4, we're going to times on the left. Now that gives me 2 single brackets to expand. So on my numerator of my left fraction, I have x times x minus 4, which is x squared minus 4x. And on my right fraction, I'll do the denominator in a second, we have 2x times x plus 2. So 2x times x is 2x squared, 2x times 2 is 4x. I need my denominator. Now, most of the time, I don't actually need to expand the denominator. I can just leave it as a double bracket in this case, and that's what I'm going to do. I'm just going to leave it as x plus 2 and x minus 4. The only time I would need to expand it is potentially if I wanted to look at simplifying it, in which case it's better to be factorised anyway, or if the question asked me to write my answer in a certain form. Typically it might say something like ax squared plus bx on the bottom or something along those lines, where it indicates to you that it does need to be expanded. This one doesn't, so I'm going to leave it factorised. I'm going to collect like terms on the top. We have x squared plus 2x squared. That gives us 3x squared. And on the bottom, we have a minus 4x and a plus 4x. Now that's quite nice because they actually cancel each other out. So we're just left with 3x squared on the top, and on the bottom, we just have our bracket x plus 2 and x minus 4. And there we go, that is actually our final answer there. Just watch out, if this was a subtraction, you would have to be very, very careful because both pieces on the right here would be subtracted. And if we were subtracting, this plus 4x would become a minus 4x, as we would be subtracting 4 instead. So just watch out for your negatives, but again, as I said, lots of practice questions in the video in the description you can have a look at for this one. Do double check the answer, do see if it simplifies. Here there's no factors that are shared on the top and the bottom, so it doesn't simplify. That would be our final answer. So we'd write that 3x squared over, and you can expand the bottom if you want. You're not necessarily going to gain any marks for it unless it asks you to write it in a particular form, so just watch out how the answer is phrased. That one there, quite a nice one, just getting a common denominator in terms of algebra and adding them together. Okay, so in this question we have a non-right angled triangle called ABC. This is the triangle ABC, has an area of 21.3 centimetres squared. Work out the length of AC. So AC is our length over here between A and C. It says give your answer correct to 2 significant figures. So for this one here, we are using half AB sine C as we are given the area and it's a non-right angled triangle. So our formula, area, is equal to half AB sine C. In the formula, the angle that we're using is the angle C. Here, C is already on that angle. If it's not, we'll just write over the top of it, but in this case it is. Opposite that is our side C, which we don't need in this formula, and the other two sides are A and B. You can label A and B in whichever order you want, it doesn't matter, as in the formula they are just getting times together, and it doesn't matter what order you times them together in. So here we are actually given the area, so we would put that in place of the area. 21.3 is equal to a half times A, which we've got as 11.2, times B, which we don't have, so that's our unknown, times sine 118, and I'll put that in a bracket because that's how it will be shown on the calculator. So we need to find the missing value that is going to give us 21.3 as our answer here. Now, of course, we could guess values. It would probably take us a lot of time, and we want to sort of do this in a nice quick way. This is just a 2-mark question here. So here, what we can do is take all of the pieces on the right-hand side and do one of two things. We can either times them all together and get an answer for those, and then divide both sides by that. Or you can actually just do this in one step. Now, it doesn't look very tidy, but I can just do 21.3 and divide it by all of those pieces on the right-hand side that I want to divide over to the other side. So it'd look a bit weird because we have a fraction within a fraction, but it's absolutely fine to do as long as you're happy typing this on the calculator. Over sine 118, and that's going to give us the value of B. So I'm going to type that all in. Of course, you don't have to. You can times all of those things together and then divide by 21.3 by that number. I do tend to use 0.5 when I type it into a calculator, just because it looks a little bit nicer than typing in 1/2. But there we go. Once we type it all in, you can check this on your calculator as well. Make sure that you get this. But I get B is equal to 4.3078. There are a few more decimals, but this particular question did only want it to two significant figures, and that comes out as 4.3 for me, as it's a 0 after the 3 there. So my answer is 4.3 to two significant figures, and there is the missing side length. You can also have questions like this where you have to find the missing angle. The only difference there is once you divide all the three pieces under, if it was an angle, it'd be these three here. You would get a sine C is equal to, and you've got to do the inverse of sine when you are finding an angle that's missing. So there we go, that is area of a triangle, and that one there was in reverse using the formula. Okay, our next question, we're looking at some depreciation. It says Stefania bought a new car 3 years ago. At the end of the first year, the value of the car had decreased by 12.5%. The value of the car then decreased by 10% each year for the next 2 years. At the end of the 3 years, the value of the car was £17,010. Work out the value of the car when Stefania bought it. So when she bought the car, we've got this unknown value. Let's call it X. Then it gets decreased by 12.5%. Now 100 take away 12.5 tells us the percentage that it's gone down to. So 100 take away 12.5 on the calculator is 87.5. Now to get that, we just use the decimal version of 87.5. So that's 0.875. Again, when you get 87.5, you actually can just type in your percentage button along with that. So I can press 87.5%, press equals, and it gives me that multiplier. So that's what would happen in the first year. The next year, it's going down by 10%. And 100 take away 10 is 90, and the decimal version of 90% is 0.9. So we would times by 0.9. That's going to happen for another year as well. So we have another times by 0.9. And at the end of that, it says the value is £17,010. Now all we need to do is work back in time. So instead of timesing by 0.9, we're going to divide by 0.9. And then divide by 0.9 again. And then divide by 0.875. Now the 0.9 part, that's done for 2 years, so you could divide by 0.9 squared. You don't have to, but it will do that one for you in one step. I'm just going to divide by 0.9 to start with. I'm going to actually just write each of these values out as we go. So we get 18,900. Divide by 0.9 again, that's 21,000. And then divide by 0.875. And that comes out as 24,000. And there we go, there is our final answer. The value of the car was £24,000. And that was 3 years ago. And that's reversing depreciation. So there we go, starting out. And this works as well, even if you are looking at the kind of opposite topic to this, which I guess you would say is the compound interest, where you are given the value at the end and you have to work backwards. Those would obviously just be 1 point multipliers as they would have originally increased in value, and we'd be going back to the start. But there we go, that is some reverse depreciation, and that was sort of drawing it visually using a bit of a timeline. So our next question is looking at a quadratic sequence. With most of these now, I have been using the formula method in order to find the values of a, b and c. Every quadratic sequence is written in the form an squared plus bn plus c, and each of these values has a little formula we can use to find them. So the first step for any quadratic sequence, or any sequence in general, is to find that first difference. So that goes up by 6, then up by 10, then up by 14, then it goes up by 18, and then it goes up by 22. You don't need to find them all, we just need to find that second difference, which goes up by 4. So there are 3 formulas that apply to these starting 3 numbers. So the starting numbers, we have the 4, the 6, and the 5. And the 3 formulas we can use for that, we have 2a is equal to 4, 3a plus b is equal to 6, and a plus b plus c is equal to 5. I just need to solve them. I work from the bottom up because the bottom only has one unknown. So if 2a is equal to 4, then a is equal to 2. And I can write the start of my nth term because that's going to be 2n squared. Again, just putting the 2 in place of the a. I can now solve the next one. We have 3a plus b. If a is 2, then 3a is 6. So 6 plus b is equal to 6. So b is equal to 0. Well, rather than writing plus 0n, I'll just leave that completely. And now I'll work out what c is. So a is 2, b is 0, plus c is equal to 5. So c has to be equal to 3. So it's 2n squared plus 3. And there is the nth term of this quadratic sequence. And that one was a little bit unique there because obviously the value of b ended up being 0. Any of the values here can be 0 other than a, because if it was 0n squared then it wouldn't be an nth or a quadratic nth term anyway, but the value of b and c can both be equal to 0. So don't be put off or worry about that. If any come out as 0, that's absolutely fine. And there we go, there was our quadratic sequence. Next question is looking at perpendicular line equations. So it says the straight line L has the equation, and we have 3y is equal to 4x plus 7. It says point A has coordinates 3 and negative 5. Find an equation of the straight line that is perpendicular to L and passes through A. So when we are looking at straight line equations, for starters, any line equation we want written in the form y is equal to mx plus c. So if we have 3y, which is equal to 4x plus 7, to get it into that form, we need to divide the equation by 3. Now we're only doing this to find out the gradient. So when we divide by 3, we're going to write the 4 over 3 separate with the 7 over 3. That's instead of writing it as 4x plus 7 all over 3. We can write it like that, but I really want to focus in on this number here in front of x. Now that tells me for that line, the gradient is 4 over 3. The perpendicular gradient is the negative reciprocal. So when I get my perpendicular gradient now, all I do is I flip the fraction over, so 3 over 4. If it's positive, it becomes negative, and if it was negative, it would have become positive. So it's called a negative reciprocal. That is my new gradient for this new perpendicular line. Now in order to find the equation of the line, I just need a coordinate that's going to be on that line as well. And we're given one here, and we're asked for a perpendicular line that passes through A. So I have all the pieces. I have y equals minus 3/4 x plus c, and we have an x coordinate of 3 and a y coordinate of negative 5. So I'm going to put them in place. Y is negative 5, which is equal to negative 3/4 multiplied by 3 plus c. I need to do negative 3/4 times 3, which isn't actually too bad. It just becomes 9/4, but I'm going to type it in on the calculator anyway, because in this moment we don't need to worry about things like that when we have our calculator. So minus, we do need to worry about writing it down correctly though, so minus 9 over 4 plus c. And now I can find the value of c, adding 9 over 4 to the other side. Again, I can just type in my calculator, minus 5 plus 9 over 4. And that gives me c is equal to minus 11 over 4. And now I just want to put that back into place into my original equation where c is, and that's going to finish off my equation of the line. So we get y equals minus 3/4 x minus 11 over 4. Now you could be asked to write this into a particular form as well, which would eliminate the fractions. This one here, you can see all the denominators are 4. If you were to times them all by 4, for example, if it said, write it in the form ay equals bx plus c, or something like that, maybe it's rearranged as well, then you could times them all by 4 and we'd have had 4y equals minus 3x minus 11. There we go, and you could rearrange that into any form, but you can be asked as well to write your lines in particular ways, and that's the way to do so. But here, it just wanted the equation of the line, just said find an equation of a line that's perpendicular, and we've got that equation in the form y equals mx plus c. Okay, our next question is looking at a cumulative frequency graph. So it says the times that 48 buses left the station on Monday were recorded. The cumulative frequency graph gives information about the number of minutes the buses were delayed, correct to the nearest minute. So we have our cumulative frequency graph on the left and delay in minutes on the bottom. It says one of the buses is chosen at random. Find an estimate for the probability that this bus will have a delay greater than 30 minutes. So I want to go to my graph, I want to go to 30 minutes at the bottom, and I want to trace up from 30 minutes, again using a ruler and a pencil for any of these types of things. And there we go, I'm going to trace across. I want to find out how many buses are up to 30 minutes. So looking at the scale very carefully, that's 45 just there, just double check it, 1, 2, 3, 4, 5, so that is 44. Now this wants to know the probability that a bus will have a delay greater than 30 minutes. Well, if that's up to 30 minutes, and that's 44, it did tell us there was 48 in total, which you can see from the graph anyway, it only goes up to here to 48. Now the amount of buses greater than that is just this little gap here, which is a gap of 4. So the probability for that, we would have 4 buses out of 48. So 4 out of 48 would be our answer. Of course, you can write that in its simplest form. You can type it in on the calculator. If I type it in, it comes out as 1 over 12. Either one of those answers would be fine. Of course, you could also convert it to a decimal or percentage if you wanted. Again, similar scenario to before. I don't know why you would. It's just sort of using time that you don't need to spend. So 4 over 48 is absolutely fine there for a probability. It says in part B, use the graph to find an estimate for the median. Now watch out for the median here, because it's out of 48 buses. Yes, we're going to go to half of that, which is 24. But just watch out, because the graph, when you sort of look at it and don't read the words, it kind of looks like maybe it goes up to 50. So just be very careful. We do have to go along from 24 here. That's 24, it's 25 just above. I'm going to label both, make it really clear there that I'm going across from 24. I'm going to go across, I'm going to go down, looks like it lands on a nice number. And it lands on 10. So there we go, there is my median. My median is 10. And I've shown that nice and clearly on the graph. Part C here says use the graph to find an estimate for the interquartile range of the delays. So the interquartile range, I'm going to go from the quarters. So I'm going to halve 24, which means going across from 12. That's going to get me my lower quartile. I need to read that very carefully. That looks like 4 squares. So that's the lower quartile of 4. I'm going to do the same for the upper quarter. I'm going to add 12 to 24. So go across from 36, just there. That's 35, 36 just above. I'm going to go across. And I'm going to go down and read my upper quartile. Again, that comes out as a really nice number there. We get 20 as the upper quartile. And that's my upper quartile. Now, the interquartile range is the upper quartile, take away the lower quartile, so it's 20 take away 4, we're going to write that working out down, 20 take away 4, and that gives me an interquartile range of 16. And there we go, that is the distance between the lower quarter and the upper quarter, from 4 to 20. And there we go. That is using a cumulative frequency graph. Just remember, if you have to draw it yourself, you'll be given a table like we had in question 1. You plot it on the end points, and it's a nice smooth curve joining them all together. But there we go, that was cumulative frequency. Okay, our next question is looking at a circle theorem. Obviously, there are so many different types of circle theorems. This is another one of those topics where even if you're okay with this question, you're going to want to check out some of the other circle theorems. I'll link the lessons in the description below, and you can check out all the different lessons looking at all the different circle theorems. This particular one says that ABDE is a cyclic quadrilateral, and it tells us that ABC and EDC are straight lines. It says that angle DBC is 60, which we can see, and it says the size of angle EAB to BCD is 2 to 1. Work out the size of BCD. So let's just highlight those angles. EAB is here, and BCD is here. And it said that they're in the ratio 2 to 1. Now I would normally label that using algebra. So 2x and 1x, you can use a ratio as well, but I like to label it using algebra, particularly when it's within angles in shapes. So I want to have a look at this question to see if there's anything I can find straight away. And the big one that stands out to me is that I can find this angle here because it's a straight line. We have 60 next to it, so this is 120 degrees. Does it say to write any reasons? It doesn't say to write any reasons for this, we just need to show our working. So I guess for this here, our working, we could write 180, take away 60, and that would be enough. We now have to think about these circle theorems. There's no other angles that we can get using angles on a straight line or anything along those lines, but we do have this cyclic quadrilateral, and opposite angles in a cyclic quadrilateral add up to 180. So if that one there is 120, then opposite that is 60. And we can write, again, working out for that, 180 take away 120, because opposite angles in a cyclic quadrilateral sum to 180 degrees. So there's no other circle theorems involved here. We just have the cyclic quadrilateral, but we do have this larger triangle, which is sort of extending out of the circle. And if you have a look at that triangle, we have this angle of 60 and two missing angles, but we have an algebraic angle. So we can actually form and solve an equation for this. So in total, if we add up those three angles, 2x add 1x is 3x plus the 60, and in total that adds up to 180. Obviously, as angles in a triangle add up to 180. I can now solve this equation, subtracting 60, so 3x is equal to 120, and then dividing by 3, x is equal to 40. I want to make sure these go into the right place, so this angle here is 40 degrees, and this angle here is 80 degrees. So the question wanted me to find the size of angle BCD. BCD, we've got, it's right there, 40 degrees, and there is our final answer for this question. So 40 degrees as our final answer. And there we go, that was a circle theorem question there, only actually looking at a cyclic quadrilateral though. So as I said before, lots of different circle theorems that you can look at, so make sure you check the videos in the description. But the key on that question there was being able to look past the circle theorem and see that larger triangle that was created there with those missing angles. Okay, so in this question, we have a solid shape is made by removing a hemisphere, shown shaded, from a cone as shown in the diagram. So we have like an upside down cone and a hemisphere that's been cut out of the bottom, and we're given the volume of a cone, the volume of a sphere, and the surface area of a sphere. It says the radius of the hemisphere is x centimetres, the radius of the base of the cone is 25 centimetres, and the vertical height of the cone is 40 centimetres. It says the volume of the solid shape is 6,948 pi centimetre cubed. Work out the total surface area of the solid hemisphere that has been removed from the cone and give your answer to the nearest integer. Now, we are told the volume of the solid shape and the overall volume of that. So if we can work out the volume of either the hemisphere or the cone, then we can figure out the volume of the other piece because we have the overall volume. So if we work out, let's have a think, what we can work out, we can't work out the hemisphere because we don't have the radius, but we do have the radius of the cone and the height of the cone. And our formula for the cone is up here. We have 1/3 pi r squared h. So we can work out the volume of the cone. So for the cone, and let's put this here, we would do 1/3 times pi times r squared, says the radius is 25, so times 25 squared times the height, which is 40. So we want to type that in on the calculator. Now, when we get an answer here, we have two options. We can either write down our answer as a decimal, or we can write it down in terms of pi. Now, it will depend how complex it looks as to normally which one I choose. So this one has come out as 25,000 over 3 pi. So on my calculator, it looks like this, 25,000 over 3 pi. And that's the volume of the cone. That's completely up to you. If I convert that to a decimal, it's 26,179.93878. So just decide for yourself whichever one you prefer to write down. If you are going to write down the decimal, you need to write down all the decimals to keep this as accurate as possible throughout the question. I'm going to leave it as that for the moment. Now it says the volume of the solid shape is 6,948 pi. Now that is with the hemisphere removed. So if I take the volume of the cone and I subtract the volume of the shape that we have, what's left over, the little missing piece, will be the volume of the hemisphere. So let's do that. We have 25,000 over 3 pi minus the shape that we've got, 6,948 pi, and that's going to give me the volume of the hemisphere. So we'll label that up, keep it all nice and clear. So in my calculator, 25,000 over 3 pi, and we're going to take away 6948 pi. And there we go. Again, this comes out in terms of pi. It comes out as 4156 over 3 pi. Again, completely up to you. If you want to write down the decimal version of that, that's completely up to you. So we've got the volume of the hemisphere. And in the question, we are given the volume of a sphere formula. So we have the volume of a sphere, which is 4/3 pi r cubed. So if that's the volume of the hemisphere, then we could look at the volume of a sphere formula and we can set these equal to each other. We just need to watch out because this is for a whole sphere. So we would want to divide that by 2 or times it by a half for a hemisphere, which would give us 2/3 pi r cubed. Very nice to change that into a hemisphere formula, but it's 2/3 pi r cubed, which will be equal to this. So 2/3 pi r cubed is equal to 4156 over 3 pi. Now the easiest thing to do, first step here, is to first divide both sides by pi, as that gets rid of that pi symbol. And then we are just left with 2/3 r cubed, which is equal to 4156 over 3. Now we're doing this on a calculator, so we can quite easily divide both sides by 2/3. There are other sort of mini steps that you could do in between to make this look a little nicer, but nice and easy on the calculator to just divide by 2/3. So I've got 4156 over 3 divided by 2/3 on the calculator, and that comes out as 2078. I can now take the cube root of both of these sides, and that will give me the value of r, which is our only missing piece. So shift and then my square root of the answer, because when I press shift and square root I get my cube root, and I get r is equal to 12.76091594. Now I'm not going to round that number there, I'm going to leave it as it is because I do want my answer to be as accurate as possible here, but I now know the radius of the sphere, or the hemisphere. Now that's 12.76 to 2 decimal places, so I'm going to label it up here 12.76, just so I have a visual idea of what that looks like. And of course the question was to work out the total surface area of the hemisphere. So again, looking at our surface area of a sphere formula, I want to divide this one by 2, as that's going to give me the surface area, or whole part of the surface area of a sphere, and that is 2 pi r squared. However, you've got to be really careful with the surface area. It's not the same as volume. When we halve the volume of a sphere, it gives us the volume of a hemisphere. But when we have a hemisphere and we cut off that bottom part, it also has this additional circle that it creates on the top, because we've created another surface. When we cut it in half, we've created this circle. So that formula, 2 pi r squared, will work out the curved part. It's kind of hard to highlight on this diagram. It'll work out that curved part, but it's not going to give us that circular part that we're looking for as well. So the area of a circle, which is not given to you here, is pi r squared. So I need to, for the surface area of a hemisphere, also add another pi r squared, which can be nice and quick to do because that's just 3 pi r squared. So it's relatively nice to do. That's the formula for the surface area of a hemisphere. It's just 3 pi r squared rather than the 2 pi r squared, which was just the curved part. So now I know the formula, which is relatively nice to sort of change in that position there. I can do 3 pi r squared. We have r is 12.76, so I've got 3 times pi times 12.76091594 squared. I can type that in on the calculator. I've still got that answer on my calculator anyway, so I can do 3 times pi times answer squared, and that gives me 1534.740037, which to the nearest integer which is the nearest whole number, is going to be 1,535, and that's centimetres squared, as it is a surface area. So there we go, that would be my final answer, 1,535. So quite a challenging question there, because we had to work out the volume of the cone, take away from that the volume of the shape that we had, which found the little gap. That gave us the volume of the hemisphere. Then we worked backwards with half of the formula to find the value of r, and then substituted that into the surface area of a sphere. And I did sort of make the steps here a little bit nicer, because normally I would imagine what a lot of people would do would sub it into this formula, halve it, and then add an extra circle on. Whereas I went in and I changed the formula itself, just so that this final step was done nice and quick, just using 3 pi r squared for the surface area of a hemisphere. But lots of maths there, forwards and backwards volumes with cones and spheres and surface area, absolutely everything involved within that topic in that little question there. But there we go, 1,535 centimetres squared. Okay, so we are looking at some subject of a formula. Now here it says make A the subject of the formula, and we have an A on the left and an A on the right. So in order to make A the subject, we're going to need to get them next to each other so that we can factorise. So we visually just have the 1A, and then we can make it the subject. Now to do that, whatever's on the denominator, if there's a fraction involved, needs to move to the other side. So we're going to times by r, and that means we will get a single bracket on the left here. It'll be r times a plus 3, which you can either write as a single bracket, or if you're confident with that, we can just times them both by r. So ar plus 3r is equal to 2a plus 7. Depending on how confident you are with changing the subject, we can move stuff in one go, so left and right and left, or you can do it in multiple steps. I'm going to move the a's to the left. You can also choose to move them to the right. I'm going to move them over here to the left, and at the same time I'm also going to minus 3r and minus 3r over here from the right. Now that means we will get ar minus 2a, the 3r is moving, the 2a is gone, so we have 7 minus 3r on the right. I now have all the a's on the left, no a's on the right, so I can factorise a out of the bracket, which gives me r minus 2, and that's equal to 7 minus 3r. We can now divide by the brackets, which will isolate the a, and that gives us 7 minus 3r over r minus 2. And there we go, a is the subject. We have a equals 7 minus 3r over r minus 2. Now there are two variations of the answer to this, because although I moved the a's to the left, you could have decided to move the a's to the right. Now had you have done that, you'd have got 3r minus 7 equals 2a minus ar. You would then factorise the right hand side, which gives you 2 minus r, and 3r minus 7 over here, and then you'd divide by the bracket, so you'd have 3r minus 7 over 2 minus r equals a. So that's the other variation of the answer. You'll see it looks pretty much the same as the one that we've got. It's just the two pieces on the top and the bottom are swapped around, and there we go. We have our different version of that formula, still with a as the subject, but where we moved the subject to the right rather than to the left. But there we go. That is changing the subject with some factorising. Okay, next question. We have a trigonometric graph, and this is looking at some graph transformations. So this is the cos graph. It says here's the graph of y equals cos x for negative 180 to 180. It says on the grid, sketch the graph of y equals cos x minus 2 for, and then just the same range that we have on the graph. So one of our graph transformations, if it's in a bracket with the x, it affects the x coordinates, and if it's not and it's outside, then it affects the y coordinates. This is on the outside, so it does affect the y coordinate. There's no bracket around the x to say that it's affecting the x coordinate, so minus 2 moves it down by 2. So I want to find some points that are nice and easy for me to do. We want to find 1, 2, 3, 4, 5. I'm just trying to find where negative 1 is, just there, and it crosses through 1 just here. So that's going to help us just to visualise that movement a little bit. So this point here, which is sitting at -1, will go down to -3, which is just there, that's down by 2. We have a point here on 0, which will go down to -2. We have a point here on 1, which is going to go down to -1. This 0 again goes down to -2, and this -1 goes down to -3. From there, I just want to draw that in, making sure I go through all of these key points, trying to replicate as best as I can how the curve looks above. And there we go. There is my cosine graph moved down by 2. Now part B here says the graph of y equals cos x is reflected in the x-axis. Write down an equation of the reflected graph. Now the reflection in the x-axis, if we think about the actual curve here, I'm going to go for this point here. If I reflect that in the x-axis, which is this horizontal line here, that point would reflect up to here, and it's the y-coordinate which changes. Now if the y-coordinate is changing, then it's not a piece that goes in the bracket with the x. So with the reflection, it's a minus symbol, and it goes not with the x, but outside of the bracket at the start. So this will be at the start of the cos. So I'd write it as y equals minus cos of x. And that would be the equation there. If it was reflected in the y-axis, it would be y equals cos of minus x, like that. Okay, and you'd have the little minus actually with the x, but this one here is reflected in the x-axis, so it's affecting the y-coordinates, or more specifically, it's changing the symbol of the y-coordinates, which is a reflection in the x-axis. So y equals minus cos of x, and there we go, there is the equation of the reflected version of the graph. But there we go, that was looking at some graph transformations on a cos graph. Okay, so this question says the curve C has equation y equals 2x squared plus 4x plus 3. The line L has equation 8y minus 8x minus 15 equals 0. Show algebraically that C and L have exactly one point in common, and you must show you're working. Now this is a variation of a quadratic simultaneous equation. It's just that it's not a circle meeting a straight line, it is a quadratic graph, which is a curve. So here we are going to take the approach of, and there are two ways of doing it. You can either try and create the substitution method, which is the same as when you have a circle, you have to substitute in, or we can make this the y equals method. So here it's easier to have them both as y equals, so it's actually a little bit nicer than some of the other questions. However, it does look like some quite challenging numbers in here because we're going to need to make this y equals. So for starters, I can add 8x and add 15 to the other side. So that's 8y is equal to 8x plus 15. I can now divide by 8. That'll make it y equals. And I get y equals 1x plus 15 over 8. So there is my equation of the line. And my equation of the curve is already y equals. So now that they're both y equals, I can do what's called setting them equal to each other. So I can write 2x squared plus 4x plus 3 is equal to x plus 15 over 8. Now to solve a quadratic, we have to make it equal 0. So I can minus x from both sides. I'm going to do this in steps because there's quite a lot here. So 2x squared plus 3x plus 3 equals 15 over 8. Now I need to subtract this 15 over 8 from both sides. So minus 15 over 8, that will go away from the 3. And I'm just going to type that bit into a calculator. So 3 take away 15 over 8. That gives me 9 over 8. So I get 2x squared plus 3x plus 9 over 8 equals 0. And there we go. Right, so I have a quadratic equation here, which is now equal to 0. And I have two options really as to how I might go about approaching this. Now, either I could try and factorise it, which doesn't look particularly nice because it does have the fraction at the end, which isn't the nicest to do. Or I could try to multiply this whole equation by something to eliminate the fractions. That would work as well, and then maybe I can factorise it. Or I could straight away just use the quadratic formula. Now even still, even with 9 over 8 in there, it's not the nicest to substitute into the quadratic formula. So you could do it from here. At this point we would have a equals 2, b equals 3, and c is equal to 9 over 8. Or I could times this whole equation by 8, and then I'll just get nice whole numbers. Doesn't really matter, but I'll get 16x squared plus 24x plus 9 equals 0. Remember, I can do that because it doesn't matter if I times 0 by 8, it's still 0. But now I do get nice values for a, b and c. So I'll get a is 16, b is 24, and c equals 9. Now it really depends. You could still use the quadratic formula here. If it only has one point in common, then typically that means it probably does factorise, or it should factorise. But as you have the quadratic formula anyway, minus b plus and minus the square root of b squared minus 4ac all over 2a, why sit and try and factorise something when that formula is going to be so nice and quick for us to use? So all I need to do is put the pieces in place. So minus 24 plus and minus the square root of 24 squared minus 4 times 16 times 9. And that's all over 2a, which is 2 times 16. So typing this in, we get minus 24 plus the square root of 24 squared minus 4 times 16 times 9 all over 2 times 16, and it gives me the answer minus 3/4. So we have, and that was using the plus symbol, we get x is equal to minus 3 over 4. And if I go back into my quadratic formula and I do it with the minus symbol, I get x is equal to minus 3 over 4, which is exactly what we were looking for. So we have the same x solution, which means there's only one x solution. Only one solution for x. And of course, if there's only one solution for x, that means we're definitely only going to get one solution for y. But here's our formula here for finding y. Y is equal to x plus 15 over 8. So y is equal to x plus 15 over 8. Just got to make sure, because who knows, maybe this would give us two solutions. It's not going to, but we get y is equal to minus 3/4 plus 15 over 8. We can substitute that in on our calculator. So minus 3/4 plus 15 over 8, and that gives us 9 over 8, or 1.125. So y equals 9 over 8. And there we go, only one solution for y. So show algebraically that C and L have exactly one point in common. We've shown of all of our working. We've made it very, very clear here. We would have one solution in common. X equals minus 3/4 and y equals 9 over 8. And there we go. There is our one solution, and that was using a y equals method. And we had some quite tricky work there with the quadratics, but thinking about how we could amend that to make it a little bit easier, and using the quadratic formula to get our answer. Okay, so there we go. There was our quadratic simultaneous equation. So for this question, we are looking at bounds, and this particular bounds question is also looking at distance and time and asking us to work out a speed. So we are looking at speed, distance and time. Now this one is asking us to work out an average speed, and it says by considering bounds. So we're going to have to work out the upper and lower bound in this scenario. Now first things first is to look at the numbers in the question and write down our error intervals. So our 10.6 is correct to the nearest 0.1. So that is going to be, and we can label this as the distance with our error interval, and that'll be 10.65 and 10.55. And that is our distance error interval. The time is a little bit awkward here because it's in minutes and seconds, and it wants our speed in kilometers per hour. Now we can convert this either into minutes, into hours, or what I think is a little bit nicer here is into seconds. We can always convert the speed later on. It's nice and easy to move between seconds, minutes and hours. So here we can do 31 times 60. That'll tell us the total amount of seconds in 31 minutes. and then we can add the 48. Now that comes to 1,908 seconds. So for our time error interval, which is correct to the nearest second, our upper bound for that would be 1908.5 and 1907.5. So we just need to remember as we go through this that we will be working at a speed in kilometres per second. So our formula for speed, distance, time is speed is equal to distance divided by time, which you can write as a formula triangle if you want. This one here, we're just working out speed, so we just need to do distance divided by time. So we're looking at bounds when there's a division involved, and we want to get the biggest and the smallest. To get the biggest possible answer, we want to do the biggest on the top divided by the smallest on the bottom. So our upper bound, the biggest possible value, will be 10.65 divided by 1,907.5. I'm going to leave myself some space because I'm going to have to do a conversion as well, because that's going to be in seconds. But for my lower bound, I'm going to want to do my smallest distance in the biggest time. So 10.55 divided by 1,908.5. I can type those into my calculator. So 10.65 over 1907.5. That comes out as a very, very small number. So what I'm going to do, rather than writing that down, because there's so many decimal places, I'm going to straight away times that by 60 on my calculator. That now turns it into minutes. And then I'm going to times it by 60 again, and that's going to turn it into hours. So my speed there is 20.0996062. I'm going to do the same for the bottom. That's in seconds, so we'll times it by 60, and then times by 60 again. And let's type that in, 10.55 over 1908.5 times 60 times 60. And that comes out as 19.900445338. So there's my two answers. My upper bound for the speed is 20.09 and my lower bound for the speed is 19.9. So there we go, 20 kilometers per hour and 19.9 kilometers per hour. Now what I need to do is I need to have a look and see if there's any way, as accurate as I can, that these will round the same. Now I can kind of jump in at around 2 decimal places because I can see already they're not going to be the same. That one there is going to be 20.0 and the 9's going to round up, so it'll be 20.1, and the bottom one is going to be 19.9. So to 2 decimal places they don't round the same. Let's go to 1 decimal place and see if they round the same. We have 20.1 and again 19.9, so that doesn't work as well. And let's go then to 2 significant figures. The top would round to 20. The bottom, as it's a 9, also rounds to 20. So to 2 significant figures, this rounds to 20, and this also rounds to 20. So I would write 20 because, and just say, they both round the same to 2 significant figures. And there we go, there is my reason. And there is my answer, where I have considered both the bounds and got a final answer out of those 2. And there we go. So that one there, I could write that all on the dotted line. I'm not going to rewrite it, but there we go. We have worked out the speed. We used our error intervals. We were very careful doing the largest divided by the smallest and the smallest divided by the largest there to get our upper and lower bound. I've lined them up, and notice how I've lined them up very carefully so that I can make a very easy comparison. If one's on the left, one's on the right, it's not quite as easy to compare. So I like to line them up like this, so one's right above the other, so I can see them very nice and clearly. And then I've got my answer, and I've written a very small reason there, just because they both round the same to 2 significant figures. You could say to the nearest whole number there, but I do prefer the use of significant figures. And there we go, that was some bounds, also including some compound measures. And I will link a video in the description looking at different variations of this topic with different compound measures. Okay, and looking at some vector proof. Now again, this is one of those topics where all questions are so different. There are some relatively nice vector proofs, and there are vector proofs that involve ratios. There are some vector proofs that involve unknown constants that you have to find. Again, I'll link all the videos in the description. I've got loads going over different types and the hardest possible vectors, but this question here is a relatively, middle of the ground one. It's still complex. All vectors are quite complex, but this one here is quite a nice one, I think. So P is the point on OX, such that O to P to X is 1 to 2. So that means the point P splits this line O to X in the ratio 1 to 2, which is 1/3 and 2/3. And O to X is the vector A. We also have O to Y is the vector B, and we are told that R is the point on that, such that O to R and R to Y is in the ratio 1 to 3. So that's going to split it in the ratio 1/4 to 3/4. So that's all the information that we've been given. It now asks, work out in its simplest form the ratio Z to P, Z to R. So thinking about what that means, just in terms of the final step, it wants the ratio of Z to P, the full length of the line, and this part just next to it, Z to R. So we need to find that unknown line. So that's the whole goal here, really. Now there's two vectors there. You've got Z to P, which is the full length of the line. That's normally the easier one to find. So let's just have a think about how we could find Z to P. Now to get from Z to P, and if I highlight this in a different colour, to get from Z to P, we could go from Z to O, and then from O to P. So if we want to do this, to get from Z to P, I'm just going to write down what I'm going to do. That would be equal to Z to O plus O to P. And I want to try and find those two separate vectors. And that'll be part of the question done, because that will find Z to P. So to do that, can we get from Z to O? Well, Z to O we can do, because this is a parallelogram. Z to O is exactly the same as Y to X. So if we just look at Y to X and think about how we would get to there, well, to get from Y to X with the vectors that we've been given, we have to go minus B backwards through that B line, and then plus A. So minus B plus A would be Z to O or Y to X, depending on how we look at it. So Y to X, if I write that up here, is minus B plus A. Normally, I'll change those round so the minus is in the middle, so A minus B. Now that is the same as Z to O. So over here, where we're looking at our vector, we have A minus B. Again, this is part of the Z to P that we're trying to work out. So now that I've done that, from Z to O, I've got down to here. I now just need to get from O to P. That O to P there is a fraction of A. It's 1/3 of A. So I'm going to add, as it's positive A, 1/3 A. There we go. Now that is Z to P. I do want to simplify this. I want to make sure it's written in its simplest form. I've got 1A plus 1/3 A. So that is 4/3 A minus B. So 4/3 A minus B, that is the vector Z to P. Now there's quite a lot going on in these questions, so I'm going to highlight that because that's my key vector. That's one of the ones that I need. I now need to look at the next one. So let's get rid of all this highlighting because now we need to have a look at the vector Z to R. So how could I get from Z to R? Well, I can go from Z to O, which we've just worked out. And let's write this down. So Z to R, that's equal to Z to O. And then we can go up this line to R. So from O to R, so plus O to R. And again, I just want to find these two vectors. So Z to O we already have, that's A minus B. And then O to R is 1/4 of B, so plus 1/4 of B. And again, this is Z to R. I'm going to keep it all super nice and labelled. So Z to R, if we simplify this, is and that's minus 1b, add a quarter, so that's minus 3/4. You can do that on the calculator, minus 1 plus a quarter, so a minus 3/4 b. So there we go, there is z to r. Now I need to be able to compare these because it wants me to find the ratio of one to the other, and at the moment they have different coefficients. Now this one down here, and either of them, to be fair, we could look to factorise them, but if I factorise one of them, and let's just see if we get relatively close. Now what I can do is I can factorise 4/3 out of this, because remember this one has an a at the front, and if I want this to just have an a at the front, I'd have to factorise 4/3 out. If I factorise 4/3 out, we get the a. We're going to get a minus. I just need to figure out what goes in front of the b there. So the number in front of b is 1. So I'm doing 1 divided by 4/3. You can type that in on the calculator. We can do it relatively quickly without a calculator though. We just times by the reciprocal. 1 times 3/4, which is 3/4. So I get 3/4 b. So if you have a look, that actually matches now the other vector. It's a different multiple of the other vector, but it matches the other vector. So I've got my two vectors. I've got z to r, which is one lot of a minus 3/4 b, and I've got this other vector, which is 4/3 of a minus 3/4 b. So if I'm thinking about the line here, the full length of the line is 4/3. Let's sort of draw this in. Let's use a different colour. Let's use green. So that there is 4/3 of this vector. This line here, although a strange way to write it, is 3/3 of the vector, because it's one lot. And the little gap then is the extra 1/3 of the vector. So if I want to write this as a ratio, well, it's a bit of a strange one because it's the full length of the line first, which is 4/3, and z to r, which is 3/3. So just in terms of thirds, I've got 4/3 to 3/3. Now, normally we wouldn't write it as a fraction like that. It does want it in its simplest form. So if we times them both by 3 or remove the fractions, we end up with 4 to 3. If it's 4/3 to 3/3, that is the ratio 4 to 3. And there we go. That is our final answer. That final step there, I think, is the hardest part. I mean, if you've managed to get to that stage, you've picked up the vast majority of the marks anyway, but spotting the factorisation to get the matching vector, I think, is quite tricky in that scenario. And then just being really careful. This did have, I do think that's not the nicest of steps there, because it's the full length of the line to part of the line. If it was z to r, r to p, that would be 3 to 1, but different variations of that you could be asked. But there we go, that was the vector 4 to 3, and that was some vector proof. Now, of course, as I said, so many of these questions are completely different. So it is a really important topic if you do want to master vectors, and vectors is one of those topics where as long as you've got everything else, great, spend your time, have a look at mastering vectors. But if you've not got everything else perfect, I wouldn't worry a massive amount about the final step here. With a vector question, it's always just about finding the unknown line. Let's just remove some of this so we can have a look. So in this question, the unknown line was this one here. So even just getting yourself confident enough just to find the unknown line is a really good step with vectors. And then if you've got everything else mastered, great, have a look at these final steps if you're trying to, achieve perfection with these topics. But there we go, vectors is definitely a very complex topic and definitely one of those ones where, I've got lots of videos on that you can have a look if you want to. But there we go, there was vector proof. That was the last question, so that was the end of the paper. Hopefully you found that useful and helpful. Of course, finishing on quite a tricky one there, and as I said at the start, this doesn't cover every single topic that hasn't yet appeared on the papers. So there are some other topics to make sure that you cover. I will have some more videos coming out that show that, but do make sure that you have a look at the checklist, which is linked in the description, and then you can get a full coverage of all those topics and make sure that you revise everything. But there we go, that was the end of that video, and I will see you for our next one. And as always, best of luck for your exam if I don't, but hopefully I'll see you for our next video.